So in 8.3 part 1, we talked about geometric sequences. What is a geometric sequence? What are we doing to get from one number to the next in a geometric sequence? Multiplying. So here we still have geometric sequences, but we are going to be finding the sum of our geometric sequences. So we have two different sum formulas. The first one we're going to talk about is finding the sum of a finite geometric sequence. Finite is the opposite of infinite. Infinite goes to infinity. Finite means that it has an ending. So it ends. It's going to have a start and an end. So our formula for the sum of a finite geometric sequence is this here, where a sub 1 is the first term, r is our common ratio. It's always going to be the number that has the exponent in our question here. So most of the questions will have this little summation symbol. This symbol means that we're finding the sum. R is going to be the number that has the exponent, so it's going to be the base, or it's our common ratio. And then n is going to be the number of terms. Now, if our summation starts with 1 and ends with whatever number, that number on top is going to be our n. That's going to be the number of terms. But it's not all the time that it's going to start with 1. If it doesn't start with 1, we have to figure out what our n is or how many terms we have. So to find our n, we would do the top number minus the bottom plus 1. So let's look at our first example here. So we want to find the sum. So we need to find our first term, our ratio, and the number of terms. So to find the first term, we always take the number on the bottom, so the first number that we start with, and we're going to plug it into the n, or we'll plug it into the I or the k, or whatever our variable is in the question. So here we have 4 times 0.3 to the first power. So we can put this in our calculator. 4 times 0.3 would be 1.2. Now to find r, r is the base. So that's the number that has the exponent. What number has the exponent here? What number has the exponent? 0.3. So that would be our r. It is just the base that has the exponent, so it is not including the 4. It's just 0.3. And then n is our number of terms. We could do top minus bottom plus 1 here. But since it starts with 1, we know that whatever it ends with is going to be our n. But if we did top minus bottom, it'd be 12 minus 1 plus 1, which would just be 12. So our n is 12. So top minus bottom plus 1 works every single time. Now let's plug everything into our formula. So our sum is equal to the first term, which is 1.2, times 1 minus r, which is 0.3, to the power of n, to the 12th power, over 1 minus 0.3. Now I would say the hardest part of this question is just putting it in the calculator. So be careful with your order of operations. We are going to work with the parentheses first, so inside of our parentheses. I always like to do the bottom first just to find out what number that is. I'm going to write it and keep it on the bottom. That way I can almost just keep everything else in my calculator. So I'm just going to do 1 minus 0.3. We get 0.7. So the sum is equal to 1.2 times 1 minus 0.3 to the 12th power over 0.7. On the top, you cannot do 1 minus 0.3 and get 0.7 and then raise that to the 12th power. You have to do the exponent first. So we have to do 0.3 to the 12th power. So I'm going to do 0.3, raise that to the 12th power. you're going to get, depending on your calculator, you'll probably get an E in your calculator. It'll be 5.3144. It says E to the power of -7. This just means that it is a super small number. Don't think that you did something wrong if you get an E in your calculator or if you get a whole bunch of 0.00000. Keep the number in your calculator. The E is going to go away when you work it out. So then we're going to do 1 minus, I'm going to copy and paste that answer. So on top here, we have 0.9999, a whole bunch of nines. It keeps going. Keep it in your calculator. If you're not confident in your copying and pasting abilities in your calculator, then write down every single decimal that the calculator gives you. But to get the most exact answer, keep it in your calculator. I'm going to take this answer and divide it by 0.7. So then we get 1.428. It keeps going. I'm going to leave the number in my calculator and then multiply it by 1.2. So our sum is 1.714. We'll round to 3 decimal places. All right, let's look at the next one. So here we're going to do the same thing. We want to find the sum. Let's identify our first term, our common ratio, and the number of terms. How would we find the first term? Perfect. Take 3 and plug it in. So whatever the number on the bottom is, that's what we plug in. So we have 5 times -1/2 to the power of 3 minus 1. So we can put this in our calculator. Be careful when you put it in the calculator, especially when you have fractions. Make sure you use parentheses. So if you put it all in at once, definitely use parentheses. So I'm going to do 5 times parentheses negative, I'll call it 0.5 since it's the same as 1/2, to the second power, because 3 minus 1 would be 2. So you should get 1.25 when you put it in the calculator. What is R? What's our common ratio? What number has the exponent? -1/2. Perfect. So that's going to be our R. To find N here, we do top minus bottom plus 1. So our top would be 16 minus 3 plus 1. 16 minus 3 would be 13 plus 1 would be 14. So our N is 14. So we do the top minus bottom plus 1. Let's plug it into our sum formula now. So we take our first term, 1.25, times 1 minus R, so 1 minus negative, I'm going to call it 0.5 just to make our lives a little bit easier. It'll be easier when we put it in the calculator. To the 14th power. Over 1 minus -0.5. So my sum is going to be 1.25. I like to do the denominator first just so I can write that down. Make it a little bit easier. 1 minus -0.5 would be 1.5. So now let's put this in our calculator. You have to do the exponent first. You cannot do 1 minus -0.5 on the top and then raise it to the 14th power. That 14th power is only attached to the -0.5. So you have to do that first. So we have -0.5 to the 14th power. So again, I get an E in my calculator, but that's fine because I'm going to keep that number in my calculator and do 1 minus the answer that I just got. So we got 1.25 times, on top, I now have 0.99993. It keeps going, but I'm going to leave it in the calculator. We're going to divide it by 1.5 now. So you should get 0.7 0.66662. It keeps going, but we're going to leave it in the calculator. And then multiply it by 1.25. So we should get 0.8333. I'll call it. I'll round this to 4 decimal places. On the test, it'll be specific how many decimal places. It'll either be 3 or 4. All right, next thing we're going to talk about is an infinite geometric series. So an infinite geometric series goes to infinity. So we'll either see an infinity sign on top of our summation, meaning that it's going to go to infinity, or we'll have our sequence that ends with a dot, 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 meaning that it keeps going forever. So it'll go to infinity. So if it does not have an ending, we're going to use our formula for the infinite geometric series. So our infinite formula is a sub 1 over 1 minus r. It's a lot less work when we have our infinite, because we only have 2 things that we have to plug in. It's not as crazy of a formula. What's a sub 1? The first term. And then r is going to be our common ratio, which is going to be the base of the exponent. So the base, the number that has the exponent. Let's look at a. So a, we see that it goes to infinity. So we know we're going to use our infinite sum formula. So a sub 1 over 1 minus r. So first thing we need to find is our first term. How would I find the first term? Plug in what? Awesome. We plug in 0 into the n. Perfect. Whatever the number is on our bottom, we're going to plug that into the n or the I or the k, whatever the variable is. So we have 4 times 0.6 to the power of 0. You could put this in the calculator if you want, but what's 0.6 to the power of 0? 1, and 1 times 4? 4. Awesome. Then we need to figure out what r is. What's r? What's r? 0.6. Awesome. R is the base of the number that has the exponent. So let's plug it into our formula now. Our sum is going to be the first term, 4 over 1 minus 0.6. So we can plug this all into the calculator at once. 4 divided by, make sure you use parentheses if you put it all into the calculator at one time. So 4 divided by parentheses, 1 minus 0.6. What do we get? 10. Let's look at B. So for B, it has that dot, dot, dot. We're adding each term, so it's looking for the sum, but it also has dot, 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 meaning it goes on forever. So we're going to use our infinite sum formula again. So a sub 1 over 1 minus r. So we need to know what our first term is. Let's find our first term and our common ratio. What's our first term here? 3, perfect, right here. 3 is our first term. To find our common ratio, when we want to see what are we multiplying to get from one term to the next term, we can put that in our calculator. To find our common ratio, we do the second term divided by the first term. So we would do 0.3 divided by 3. What do we get for r? 0.1. Perfect. So let's plug this into our formula. So our sum is our first term, 3 over 1 minus 0.1. So when we put this in the calculator, we get 3 divided by, I'm going to put the denominator in parentheses, 1 minus 0.1. We should get 3.3333. Keeps going. C. Let's find our first term and our common ratio. It says that it goes to infinity. So we know that we are using our infinite sum formula. How would we find the first term? What do we do? Awesome. We're going to plug in 1 now into the I. So whatever the number is on the bottom, we're plugging that in. So we have 6 times 1/3 to the power of 1 minus 1. 1 minus 1 would be 0. What's 1/3 to the power of 0? 1. And 6 times 1 is 6. So our first term would be 6. What is R? 1/3. Perfect. So let's plug this into our formula. Our sum is equal to a sub 1, so 6 over 1 minus 1/3. Now, if you put this into the calculator all in one swoop, make sure you use parentheses. I'm going to put parentheses around the bottom, but I also have a fraction here, so I want to use parentheses around the fraction too. So just be careful. Make sure you practice putting this into your calculator and getting the correct answer. We have 6 divided by 1 minus, I'm going to put parentheses, 1/3. Close my parentheses. What do we get when we put this in the calculator? 9. Awesome. So that would be our sum.